In this video, we're going to solve a problem involving similar shapes, but also Pythagoras theorem. Now, we've got this big triangle and we've got a square inside of it, and we've got to work out x. Now, firstly, note that this triangle here and this triangle at the bottom, we say they are similar. And what we mean by similar is that they're the same shape, but maybe different sizes. So all the lengths are scaled in the same way. If you double one length, you would have to double another length, for example. And the reason we know they're similar is because they have all the same angles, so therefore they're the same shape. So, for example, this 90-degree angle is the same as this 90-degree angle. And we also know that this angle here is going to be the same as this angle here, because if you think about it, these lines here are parallel, and so these are corresponding angles, F angles, you might have heard them described as. Okay, so they're similar, so all the lengths must scale in the same way. Now, we know the bottom length of the yellow triangle is 36, because that's just opposite sides of the square. So if we draw out these triangles separately, it might help us solve this. So we've got the yellow triangle and the purple triangle, like that. And what lengths have we got? We've got the 36 here, the 45 here, and we've got the x here. Now, we also know that this is 36 here, so that height of the purple triangle is 36. Now, we need to find the scale factor of length, but we need to find two comparable sides. But the trouble is we don't have comparable sides. For example, we know this height of the purple triangle, but we don't know the height of this one. But if we use Pythagoras theorem on this triangle here, we could find that blue length and therefore work out the scale factor. Now, how do we do that? Oh, let's just identify this as a right angle. Well, Pythagoras states that if you take one of the shorter length squares, so let's call this A, and square it, and you add the square of the other shorter length squared, you get the length of the hypotenuse C squared. So Pythagoras theorem is A squared plus B squared equals C squared, where A and B are the shorter two lengths of the triangle. So the A here is, we'll just call it A. The B here is 36, so it's 36 squared, and the C here is 45, the hypotenuse, so 45 squared. So then we could just subtract the 36 squared from both sides, and then to get rid of that squared, we square root both sides. And if we do that on our calculator, we get 27. So A is 27. So now we worked out that this length here is 27. So we've got enough information now to work out the scale factor, because the scale factor between the left length of each triangle, well, we just do the second number divided by the first. So 36 divided by 27 is 4/3. So the scale factor between lengths is 4/3, which means that this hypotenuse here, this longest length of 45, it's got to scale by the same number. So it's got to also get 4/3 times bigger. So we know, therefore, that if we take 45 and multiply it by that scale factor of 4/3, that's going to give you x. So we do that, 45 times by that 4/3, that means that x is equal to 60. And that's the final answer. We've worked out that x is 60 centimetres.